Hello everyone, welcome back to your YouTuber teacher, Miss Pamela. And let's continue working with simple machines problems. I hope you are having this stuff clear, but make sure to clear doubts with me. In any doubt you have, you can look for me. Terms that we need to know. We have effort or force. You can also find that word in the problems. Load or resistance. And pivot or fulcrum or application point. Okay? I like or I prefer to use the application point. Okay? But any of them will be correct. And now let's remember that a lever in Spanish is a palanca. And from there, I will just go to my problems. Let's start with the first one. A claw hammer is used to pull out a nail. The resistance arm is 4 centimeters and the effort arm is 47 centimeters. Find the resistance if the effort force is 145 newtons. And this is what I was telling you before, guys. Here we have the example. We know that the application point is right here. The distance from here to here is the force applied because we can see the hand right here. And the distance from here to your object, the object, which in this case is a nail, is a resistance. So we said that this one would be letter A and this one would be letter B. Now, in order for a lever to work, letter A needs to be always bigger than letter B. Because imagine, let's say, we already said that this one is letter B, but imagine this one is bigger and this one is shorter. Well, your hand will be right here and it would be super difficult to move it. That's why letter A, or the effort arm, where the force is applied, needs to be bigger. Okay, we'll see how it works with a mechanical advantage in that part. Okay, so let's start putting our data. In all of our simple machines problems, we've learned that we always have resistance and force. And in this type, if you remember, in the inclined planes, we have length and height. And now in this one, we'll have A and B. Another tip for you guys to remember that A and B's is that if you see it alphabetical order, A goes before B. So F goes before R. So A goes with F and B goes with R. Okay? I hope it helps you. These are the PAME tips. I'm joking. Okay, so we have a resistance arm of 4 centimeters. So we're talking about, if you see it, you have 4 centimeters and 47 centimeters right here. So if you observe your image, where would you put the 4 centimeters? Where? Well, right here. And the 47 centimeters right here. Okay? So we said this one is B and this one is A. So let's write it down. 47 centimeters and 4 centimeters. They're asking me to find the resistance, so we want to know the resistance, which is a nail, question mark, with a force applied of 145 newtons. The formula we will be using in this case will be force times A equals resistance times B. So we're searching for resistance. It means that I am bringing my letter B to the other side. As we know, if it's multiplying, we will bring it here, dividing. So we have resistance equals 145 newtons times 47 centimeters divided by letter B, which is 7 centimeters. The unit that will cancel is centimeters with centimeters. So your resistance will be equal to 145 times 47, 6,815 newtons divided by 7. you have a resistance of 973.57, or if you put a 6 or a 5, I'll put it correct. And the answer will be given in newtons, because remember, if I give you newtons, you give me newtons. And this is your answer. Now let's find the mechanical advantage. Mechanical advantage of a lever will be A divided by B. So A equals 47 centimeters divided by 7 centimeters, 6.7. Remember, we do not have a unit. Okay, a rock of 60 kilograms rests on the end of a 2.5 meter lever and is 1 meter away from the application point. What force must be placed on the other end to balance the lever? So let's check this one out. If you want to draw your lever here, they're telling you that your lever measures 2.5 meters, okay? And 1 meter, let's say right here, is the application point. So they're telling you it's 1 meter away, a 60 kilogram rock. So you have 60 kilograms here of a rock. They want to know what force must be placed on the other end. So how much force you need to apply right here in order to balance this lever. Now, this one will be letter A. This is the longest one. And this one, where is the resistance, is letter B. Okay? So if from here to here measures 1 meter, it means that from here to here measures 1.5 meters. Right? Tricky, I know, but it's easy if you read it again. So, if you have force and resistance like always, A and B. The resistance is of 60 kilograms. Letter A is of 1.5 meters and letter B is of 1 meter. We're searching for force. If we know that force times A equals resistance times B, and we're searching for force, it means that letter A, I'll pass it to the other side, dividing. So I have force equals 60 kilograms times 1 meter divided by 1.5 meters. I will cancel meters with meters, and your answer will be in kilograms, because remember, if I give you kilograms, you give me kilograms. So you have 60 divided by 1.5 equals 40. And now you measure your mechanical advantage. Mechanical advantage equals A divided by B. So mechanical advantage equals 1.5 meters divided by 1 meter. Mechanical advantage equals 1.5. Here's your answer, and here's your answer for mechanical advantage. And now, let's start with the wheel and axle problems. What is the mechanical advantage and the resistance of a wheel and axle if the wheel has a radius of 45 centimeters and the axle a radius of 5 centimeters with a force of 35 kilograms? Okay, it's important for you to know or to remember that in this type of problems, we're talking about wheels. So we already know that a wheel is round, yes? And because it's round, we know that it has a radius, okay? Lowercase r, I'll put. And the axle is a small one. It's in the middle, okay? So, like all of our simple machines problems, we have force and resistance, radius of the wheel, and radius of the axle. This is the variation. And they're also asking me for mechanical advantage. So I have 45 centimeters and 5 centimeters. 45 centimeters, the wheel is always greater than the axle. So we have 45 centimeters and 5 centimeters. And a force applied of 35 kilograms. We're searching for resistance. So in this one, we'll have force times radius of the wheel equals resistance times radius of the axle. We're searching for resistance, so we will bring radius of the axle to the other side, dividing, because it's multiplying in the other side. So we have resistance equals force, which is 35 kilograms, times 45 centimeters, divided by 5 centimeters. Here I forgot to put the C. So resistance equals, we cancel centimeters with centimeters, and 5 becomes a 1, 45 becomes a 9. So you have 35 times 9, 315 kilograms. And your mechanical advantage will be radius of the wheel divided by radius of the axle. Mechanical advantage equals 45 centimeters divided by 5 centimeters. Cancel centimeters, and your mechanical advantage is of 9. Okay? It says, you want to raise a box of 980 newtons to a vehicle whose platform is 1.5 meters above the ground in a 3-meter long plank or in a 3-meter long inclined plane. What force is required to push the box on the inclined plane? Okay, so let's say they're talking about this guy, and they're saying that this is 980 newtons. You want to raise it for 1.5 meters, and here we have a 3-meter plank. Okay, here is your box, and they want to know the amount of force you need. So if we pass this information to the problem, let's remember the data. All of these problems need to have data, guys. So we have force and resistance always as data, and in inclined planes, it's not like in the pulleys that you don't have any more or an end. In this one, you will have length and height. So the force, we do not know it. We're searching it because they're asking me what force, okay? Then we already know that the resistance is the object that you want to move. In this case, the box. So we have a resistance of 980 newtons. And then we have a length of 3 meters and a height of 1.5 meters. Now, the formula that we'll be using will be force times length equals resistance times height. And we are searching for the force. So now we've seen before the rules. Here we have the rules. If we are adding, we pass to the other side subtracting. If we're multiplying, we pass to the other side dividing. So here is what we're doing. Length is multiplying force. So if I want to leave force by itself in one side, I'll pass length to the other side dividing. So my formula will be resistance times height divided by length. So force equals 980 newtons times 1.5 meters divided by 3 meters. Okay? The unit that you will cancel in here will be meters with meters, and your answer will be given in newtons. If I give you newtons, you give me newtons. If I give you kilograms, you give me kilograms. If I give you grams, you give me grams, and so on and so on. Okay? So we have force equals 980 times 1.5, which equals 1,470 newtons divided by 3, which will be 490 newtons. So you need 490 newtons of force to push that box into the truck. Now, let's find the mechanical advantage. The mechanical advantage will be, in this type of problems, is length divided by height. So we have 3 divided by 1.5. We have meters and meters. So that you cancel meters with meters, and you don't have any unit. And it's fine. mechanical advantage equals 2. And there won't be any unit. Okay? I send you a lot of hugs, virtual hugs, and see your happy faces tomorrow. Love you guys. Bye.